what strategies have we used in the different operations. For example, on the first one, we have something equals a number plus another one. So we know that these two, so this something would be the total, and these two would be the parts. So we have 1000 here, and we have 90 here. Now it's easier to see it. Okay, so my total would be 1090. So we need to be careful with the placeholder, okay? In the thousand, we have to write 1000. Do we have any hundreds? No, so we keep a placeholder, 9 tens and 0 ones. And here is 1090. It is. Second operation. This is an addition. We are adding two parts, so once again it would be a total equals one part and another part, one part and another part. Okay, so this is, we can't complete this quickly looking at the place value. We will have to operate, but if I look quickly, would I have to unitize? Let's see, 5 and 2, that would be 7. Then I would have to unitize here. Right, I could do that mentally. Okay, I could add my ones. 5 ones plus 2 ones equals 7 ones. Then I can add my tens. 8 tens plus 7 tens equals 15 tens. So if I want to do it like that, I would have to do 15 tens. 15 tens is made of 105 tens, so I put that one up there so I remember. And then finally, no hundreds here, but I have 100, the hundreds here, so 200 plus 100, 300. I can do it mentally like this, or I could do the column method. 275 add 82, and I would operate, always starting from my ones. Let me write the values: ones, tens and hundreds. Okay, so 5 ones add 2 ones equal 7 ones. 7 tens add 8 tens equals 15 tens. So 15 tens, I write 5 tens and I unitize 10 tens into 100. And then 200 add this one that I unitize, 300. Okay, so 2 ways to do this operation. Here, what do I have? I have a total made of 3 parts, and straight away I can spot that it is about place value. Okay, I can see the 800s here. I can see the 6 ones here. The only thing I am missing is the 2 tens. 2 tens is the same then 20 when I partition my number. So 826 is made of 800, 2 tens, which is 20, and 6 ones, which is 6. Number 4. So once again, we have a total and 2 parts. So let's visualize this. We have 341 as my total, made of 2 parts. This one that I don't know, and this one. This is 5, and this is the mysterious part. Okay, so how else can I relate those numbers? Something at 5 equals 341. If I look at it like this, something at 5 equals 341. Okay, which is the inverse operation I could do? So here I have an addition. What is the inverse operation of an addition? Yes, a subtraction. So I could do this total, take away 5, and I would have the amount, the mysterious amount. Let's do that. Can I do that mentally? Yeah, some of us might be able to do that mentally. Can I just count back? Yes, I could do that quickly. 341, 340, 339, 338, 337, 336. Yeah, that would be 336. Which other way? You could do the column method, but which is the more efficient way? Well, counting back or even visualizing a number line and making efficient jumps. So when you are doing a subtraction on a number line, you can see that in your head. And here, you can, in your head, you could partition 5 in this one that you have to take away and 4. So you could do a jump of 1 that would take you to 340, and then a jump of 4 back. Okay, so here, just to remember, we have done take away 1. That's the one we took away, and then we need to jump back 4. So 340. If I use my number bonds, take away 4, I am on 10. 10, take away 4, 6, okay? So I would have to go to my previous 10 with a 6. So 300, my previous 10 is a 30, and 6, okay? I am using my number bonds. So you can choose whichever way is the quickest for you, okay? It has to be an efficient way, a quick and accurate way. And then what can we do? Well, we should check it. Okay, so 336 plus 5 is 337, 38, 39, 40, 41, 341. Okay, that's correct. Number 5. So we have 2 addends equals a total. So what we have here is 2 addends equals a total. Look at what I see. This is just 10, isn't it? It's just about place value once again. So what is the only digit that will change in this case? The 4. Okay, we are adding 10 more. 355. Okay, this one has changed, that's all. Okay, so that is your answer, 355, and that is the most efficient way. Okay, you know that is a 10 straight away. That's your place value. You look at the digit that it will affect. Number 6, we have a subtraction. Subtraction. That means we have a total from which we take away one part. Okay, so that would be a total 424 from which we take away one part, which is 51, equals the other part. Right. How can we do that? We could do that mentally, but 2 take away 5, we might find it a bit challenging there. So I think the most efficient way there would be to do the column method. 424 take away 51. Okay, and we start from the minuend. We start from the top number and from the ones. 4 ones take away 1 equals 3 1. 2 tens take away 5 tens. That is when we have to exchange. Okay, so 2 tens is not enough, so we need to take 10 tens from the hundreds. Okay, we know that 100 equals 10 tens. Okay, so we take 100 away, therefore we have 300 left there, and we give 10 tens to the tens column. We have now 10 plus 2, 10 tens plus 2 tens equals 12 tens. 12 tens take away 5 equal 7 tens. And 300 take away nothing equals 300. So my answer would be 373. Okay, we can and we should do the inverse operation just to check that it is correct. So 373 add 51 should give me the total. Okay, 3 add 1 equals 4. 7 tens add 5 tens equal 12 tens. I unitize. 3 tens plus 300 plus 100, 400. 424, correct. We have done our operation properly. Next one. So we have 495 plus 1 equals something. Well, we know that the only one that is going to change is the ones. So 496. Number 8. 472 take away 9. So we either count back in nines or we visualize that number line and we use our number bonds. Okay, we are doing a subtraction. So 472. Now we need to do efficient jumps. We are going to jump to our next 10, 470, which is a jump of -2. Okay, so we partition 9 in 2 plus 7. Okay, 2 plus 7 equals 9. So we have taken away 2 already. And now, using our number bonds, we go to the previous 10. And we will have to take away 7. I know my number bonds. I know that 7 plus something, what did I say? 7 plus something equals 10. That something is 3. So if I take away 7, I know that I will have 3 ones. Now, it has to be my previous 10, okay? I am subtracting. My number is becoming smaller. So that would be 463, okay? Let's do it the other way around to see if our answer is correct. So 463 add 7. 3 plus 7 equals 10. Yeah, it's my next 10. 470. 470 add 2. 472. That would be correct. Okay, so I have done a proper calculation. My answer is correct. 473. 39 adds 673. So this is an addition. Can I do that addition mentally? Well, I could, but if I think I will struggle, I can use my formal method, the column method. So 673 with addition, it's commutative. It doesn't matter which one goes on top. So I know we are always more comfortable with the bigger number on top, so we do that. 3 ones, add 9 ones, 12 ones. I need to unitize. 12 ones is made of 2 ones and 1 10. 7 tens, add 3 tens equals 10 tens. Add 1 10 equals 11 tens. And 11 tens, I need to unitize. It's made of 1 10 and 10 tens, which is the same than 100. 600, add nothing. 6 and add this one, 7. So my answer is 712.